Hello all, welcome to the video lecture series on Python programming. We are going to touch upon a very important module in terms of industrial programming practices of Python, and that's related to the exception handling. Okay, we need to understand what exception actually means in context of programming, and how can we handle the different exceptions in Python, right? So that is the core objective of this session. So, what is an exception? So, I mean, we are all aware of this term called exception. What do we mean? In general, in a very non-technical terminology, what we mean is something which is not normal, beyond normal, right? So either it can be, I mean, much better than what it should be, like an outstanding student. So we say an exceptional student, or it can be meaning a negative sense of it, like say for example an exceptionally bad weather, right? We say that the weather today is exceptionally bad. So whenever there is something which doesn't I mean align with the normal expectations, we say that it's an exception, right? So same way in the coding world also, when there is something which is unusual, which is not expected from the normal execution of the code, we say that it has come across, the code execution has come across an exception, right? And this is nothing which is specific to Python. Exceptions are there, I mean, exceptions may occur, as well as exceptions need to be handled in any professional programming language. I'm sure people who have some bit of an exposure in Java or C++, you also have done the same thing. Maybe the syntax is different, right? So Python is also not different. From the different modules of Python, and due to different failures or exceptional conditions, the raised exception types are different, right? So every module, I mean, virtually every module of Python will throw certain exception based on what kind of abnormal situation it has come across. Let's take a very small example, right? What we are doing here is a small portion of code. We are trying to assign a particular list to a variable. Say the name of the variable is test, and we are trying to access one specific element of that list value, right? So let's try to do that same code in here, right, in Google Colab. So we just have a small list kind of assigned here, 1 2 3, and then we try to access one specific element of the list. We may want to print it or whatever, so we do the test3. Whenever we try to execute it, it throws an exception. What is an exception? It says index error, and it also gives a description why that error has happened. What is the description given? List index out of range. So if you now just try to delve deep, what will we find here? The index of the different elements of the list are, for 1 it is 0, for 2 it is 1, for 3 it is 2. So 0, 1 and 2 are the three indices of the list variable, which is the name of which is test. Now what we are trying to do here, we are trying to access an element with index value 3, which doesn't exist. So obviously an exceptional situation or an abnormal situation is hit, right? So that's why it throws an exception, and the type of the exception is index error. So like this, there are different other types of exceptions in Python. Some of them being, I mean, as we can see, some of them being type error, index error. We just came across the index error. Type error, whenever there is some mismatch in type, something related to the type of the variable, right? Or a Python object. Then there is a name error and value error. So different types of exceptions are there in Python, right? The most commonly thrown exceptions being these four: type error, index error, name error, and value error. Right? Now, what happens when an exception is raised? What we saw here, it's just a single line. We are doing a programming in a interactive way, right? So that's why we couldn't actually feel what has happened. But if you just put it as a part of a large programming, block, right? Large program. If you have this kind of a line of code where we are trying to access a particular element which doesn't exist. So what does happen? What happens is the program terminates abnormally. It suddenly terminates because it doesn't know how to handle this kind of a situation, right? And this is what we call in the computer science, or like the IT jargon, we say that the program has crashed. Abnormally terminated, we call it crashed, right? So this is an example of an unhandled exception. So which is a very big problem. When we have a unhandled exception, this is a big problem. The program abnormally and abruptly stops then and there. But uh, then what we do is we go back, we try to figure out from the description of the exception itself, we can get some clue, and we try to figure out what has gone wrong and why, right? This is what we generally try to do. So, but the thing is, when we have this kind of a situation, ideally this termination should not happen. Exceptions, when raised, it should be handled by the program. So abnormal and abrupt termination of the program is not acceptable. What should happen is it should have a seamless kind of alert given to the user, and the user should be able to take an action. That should be the way we need to do our programming, because otherwise if we have a large program, many such situations may occur and we have a big nightmare. Our program crashes often, right? So this is not a good situation to be in. So sometimes when we have this kind of a situation, right, we should, as a programmer, we should have a mechanism to handle the exception. Unhandled exception is not welcome, but handled exceptions are very much welcome, right? So whenever we have exceptions, there are certain things which may happen. Either there is a bug in the program which say for example what we just saw, right? The program has a bug. We are trying to access a particular variable or a particular element in a list variable or any such variable which doesn't exist. So that is one thing. The other thing might be, these are like very much like situations which we probably should know beforehand. But certain cases, there might be situations which we may not know beforehand. Those cases may also happen. But our program should be able to anticipate with and to deal with such situations, right? That's a good programming practice. So that's why we say that a well handled program should not have unhandled exceptions. When we have a well written program, there should be a provision for handling all abnormal conditions or exceptions, right? So, say for example, if we again look at another line of code, another couple of lines of code, right? Say for example, we have some number of successes, whatever it is. We just have a counter for successes and a counter for failures. And what we are trying to do is we are trying to find out the ratio between success and failures, right? And we are trying to print it. This seems to be a very harmless program, and we can very well write this program, right? Say for example, I just simply go here, okay, and write, say number of successes, num success is equal to, say whatever, we give a value 56. It's a very random value I'm assigning. Num failure is equal to say 5. Okay, and then we just calculate the ratio. So success ratio, right? Success underscore ratio. And what we do is very simple. We divide the num success with the num failure, right? With num failure. And whatever we get as a this thing, we just simply print it. So print uh, whatever we give a string, the ratio of success to failure is, and then we give a comma and we give this success ratio, right? If we execute this, a very simple and harmless program, no problem, it gives a ratio 11.2. Now, say for example, there is no failure. So this is a counter. I'm just randomly assigning a value here. But say programmatically, this value is being calculated. And say for a particular program, there is no failure which happens. So we just get the value of num failure is equal to 0. So whatever we are trying to calculate here, what is happening is a specific number of successes is getting divided by the number of failures, which is 0. What happens? Obviously, it's an abnormal situation. It's called a zero division error, right? So that means we have a abnormal situation encountered by the program where it was expecting a valid value for number of failures, but it's getting a 0 and it's trying to divide a specific integer with a 0 value, and obviously there is an error, right? So that's why we are getting an exception here, which is the zero division error, right? But this is not a good program because we have not handled the exception. In a good written program, we should have the provision for anticipating, or rather for handling this kind of situations. How can we do that? Let's see. So what we do is very simple. What we do here is we try to define a block of code to handle this kind of abnormal situations. What is the typical way of writing this kind of a code? We have to write a try block where all the programs which, or rather are lines of code which needs to be executed are being written, right? And then if there is a situation where is when there is an exceptional situation, so here we are anticipating that there might be situations where zero failures may happen. So zero success, no problem. Zero divided by something is perfectly fine. The ratio will come as zero. But if the failure is zero, that kind of condition we should anticipate as a programmer, and we should have a provision in our code to handle this situation. So what we do, we simply have a try block where the code is written, and then we define a except block where whatever exceptional condition happens, there is a particular type of, or rather there is a particular message given as an alert to the user. We can do other things also, right? We will see soon. So how do I rewrite this code now? So what I do here is simply I write this code within a try block. Okay, try block. So this obviously there should be an indentation because it's a part of the try block. So both these lines are part of the try block. Then we have a catch block, or rather it's not a catch. I mean, catch is a term in Java or C++, so that came to my mind. So it's called an except block in Python. So except, okay. And here what do? We see, sorry, okay, what kind of exception? So we have a zero division exception, right? So except, so if there is a zero division error, then what will it do? It will simply print a particular message which should be friendly for the user to understand. So you just write here the number of failures is 0. That's it. Okay. So the hence ratio not possible. As simple as that. Okay, and how do we know that we have come to the, we have finished executing? We just give a print statement here. Okay, so we give a print statement, uh, completed the completed the try or exception block. Okay, exception block. Now let me again run it. So here what you see, whenever there is a failure is 0, it simply doesn't assign this value to success ratio. It simply comes to the except block, and then it executes this print statement that number of failures is 0, hence ratio not possible. And once it is done, it comes to the outside of the try block, right? It comes out of the try block and it prints completed the exception block. If there is a valid value to it, say for example 3, then also what it will do, it will execute these two lines within the try block. It will not come to the except block because there is no exception being raised, and then it will come to the print statement after this whole thing, right? So now you understand, you write your code within the try block. How do you do that? Whenever you want to do that, you simply follow it by the indentation. Within the try block, try is the reserved keyword, then you put a colon. Whatever lines you want in the try block, you simply give an indentation to those lines of code. That means what? Those lines of code, when they are getting executed, if there is an exception thrown, immediately it will be passed to the except block or the exception block. Okay, and there the execution of the lines of code within the except block, again except is a keyword, then you give the parameter of this thing or argument as a specific type of exception. Okay, there is another option, we'll come to that a little later. So for the time being, just understand that a particular exception you anticipate that this might occur, so you want to handle that and you give the lines of code to handle that, right? And then you come out of that block, right? This is how you simply do the you handle the exceptions, the try block, the except block, and you do the lines, you press the lines of code out there, right? So that exactly is being discussed out here, right? So this is how we handle the exceptions. Now we can look at one more line of code. One more example. Say for example, we are trying to take certain values as input, and we are trying to find out the square of those values. Now, what can happen? First of all, the number which has been entered, or rather the value which has been entered, the string which has been entered, is basically a it's not a not a numeric one. Okay, so obviously whenever there is a conversion being attempted to int, it fails, because say for example I'm giving a abc as a string, input string. If it tries to convert abc to a numeric value, it's not possible, right? So that's one thing. Second, obviously if it is not a numeric value, the square of that value is not possible, right? So there should be an error being thrown, right? That it's not an integer, right? So if you just write these two lines of code, and if you try to enter, say for example, I do this. Let's just talk in terms of the code. So str input is equal to int, then I give input, and I give, say, some kind of a prompt, right? Say enter a number. Okay, enter a number, and then whatever comes here, I say that print then the square of whatever number I have given here, say strinp, okay, and then I give is colon, and then I give strinp, and then square, right? So this I want to execute, right? So here I give a very valid string, no problem, everything is fine. Now say when I give a character, a set of characters, I try to execute it. Immediately it throws a value error, right? So now this is again an unhandled exception. What should I do? Simply, as we have seen in the earlier block, we have simply we can put it in a try block, okay? And whenever there is a try block, we have to give the codes in indentation, and then we give a except block here, and we expect uh, strings which cannot be converted to integers. So we get a value error, and then uh, we give a print the input is not numeric. Okay. Now, say for example, you want to execute it now. Okay, you execute it now. Now, if you give a particular string kind of a thing, so the input is not a numeric, not numeric. But if you give a valid string, valid input also, and valid new number also, and when you do this, it's fine. There is no problem at all. It doesn't come to the exception block. It does the square and it prints, right? This is how we need to do exception handling. The same thing if we want to do in a multiple iteration. I mean, till the point we get numeric value, we want to keep on the while loop. I mean, it keep on taking inputs. That also we can write it in this form, right? I mean, this is a very simple code. We understand just a while loop until the point of time while is true. We simply keep on running this block of code, and the block of code is in a particular exception, right? I mean, it's in a try exception block, right? So this is how we can write a code which has the exceptions being handled. Again, I'm reiterating, exceptions need to be handled in a well-written code. If you handle the exception, it's fine. If you don't handle the exception, it will lead to the termination of the program, or what we call the program crash, right? Now, let's look at the same things. Basically, we can put it in a function like readint, and this is like the same block that we saw here. We can put it, I mean, one thing, yeah, that's one thing I wanted to mention. So what you see is what we could have written in just 2 lines of code. When we are trying to do an exception handling, it leads to a much larger number of lines of code. So here, these 2 lines of code are being replaced by some 5 lines of code. And it might be more than that also, depending on how we are trying to handle the exceptions, right? So that's a big pain. You might think that we are actually adding to the lines of code. But in that case, just think from this perspective that wherever there are similar kind of functionalities, we put that in the form of a generic function. Like integer checking, we can put in the form of a generic function where the codes are being put in the exception block, right? In the try exception block. So that way, obviously, you are optimizing the lines of code. So if we think of repeating those try exception blocks over and over again, obviously there is a lot of redundant code getting inserted. But when the same thing we are putting it in a generic function, then obviously the cost is not so high, right? Because it's just one function, and within that one function, probably 2 lines of code are being replaced by 5 lines of code. That's not a big deal, right? So that's how we can take care of things. Now, there might be situations, I mean, obviously you probably already thought of it, that the exceptions might not be only of one type. It might be of different types. How can we handle that? So there are 2 ways to handle that. Either you have a except block with the arguments where the arguments are of different types of exception. So for example, here we can have an except block with two types of exception, the value error and the type error. Value error when we got a value error when we were trying to divide it with 0, and type error when we were trying to convert a string to an integer, where the string was a non-numeric string. That time we got an error, right? So we got a type error exception, right? So if we want to catch both kind of things together, say for example we are writing a program where we are taking an input from the user, and that input we are trying to convert it to a int, and then we are trying to make a square of it, right? Rather not square of it, we are trying to take two inputs, right? And both of the inputs we are converting to int, okay, and then we are dividing one input by the other, right? So there, in case any one of the inputs are having non-numeric data, that time you might encounter a type error exception, right? So that needs to be handled. At the same time, when we are dividing the number with which we are dividing, if that is 0, then we are going to get a value error exception, right? So that also we need to have a provision to handle it, right? So in that kind of a code block, we need to have a provision for handling both the type of exceptions. So how do we handle those multiple exceptions? We can write an except block where we take both the type of exceptions. That's one way. The second way is, the alternate way is, we define two exception blocks. So here it's a little different. We're not going to come to that. But like here, we have a first one, say we have first one except, and we have that as a value error, and the second one val error, and the second except again we define, and that we have as a type error, right? So both of them we have different blocks defined, except blocks defined, right? So this is the way we can handle multiple exceptions in the same try except block, okay? Now coming to the next thing, are exceptions good? People say yes, they are good, but why? I mean, they seem to be unfriendly, right? We have crashes, abnormal situations, but the reality is, actually, if we are handling the exceptions in the code, it is actually good, because at the very least we are getting the specific exception being thrown out, and because the exception is being thrown out, we know that there is some problem. I mean, if the exceptions are not being thrown out, if the exceptions are not being raised, what will happen is the program terminates and we have no clue why it terminated. But when an exception is being thrown, we know exactly why the exception is being thrown. And if we are handling the exceptions, even better. We can give very clear, customized alerts and messages to the users, which helps them figure out what the problem is. So what we say is, overt bugs, that means more number of bugs, are much better than covert bugs, that means hidden bugs. So it is better to err on the side of caution. It is better to raise more errors than error being not raised, and at the same time we don't know what has happened to the program, why it is not functioning in the right way or in the expected way, right? So exceptions are actually good. Handled exceptions are even better, right? There is one more way. What we saw till now is whatever error is being raised by the system. Now there might be situations where the system is not throwing any error, okay, or exceptions, or even if it is throwing, that's not a very clear understanding why that exception is being thrown. So there you can actually, we as Python programmers, we can actually custom create the exception, or we can raise a particular exception, right? That exception can be either a standard exception type, or it can be a custom exception type. How can we do that? By subclassing one of these standard exception types. So one option is we just raise a built-in exception like a value error. The other option is we raise a particular exception which is a custom exception. We just define that exception by our own. It's a custom exception, but that custom exception is probably inherited or subclassed from a parent class which is a built-in exception, right? It is a perfectly permissible thing. Now, let's just try to look at an example to do that. Okay. So what we do is we create a code to divide two vectors. Okay. So get ratios is the function written to basically get the ratio of two vectors, vector 1 and vector 2. Both are the arguments of this function, right? Now, for example, we don't have this raised exception, right? We just simply have this thing. So what does it do? It simply checks whether the second vector is a 0 or not. In case it's a 0, it throws an exception. So let me write a, let me call this function. So get ratios. I keep it very simple. I just try with the two vectors having one element each. So say for example 24 and then another one, say 3. Okay, first we will try the happy path. Okay, we just give two valid vectors 24 and 3. When they are divided, there is some problem, I believe. So okay, and I give a try block for, yeah, so I think the indentation was not proper. Okay, so this should be fine. So I give two exceptions. So get ratios 24 is not defined. Okay, I'm sorry, here the R needs to be caps. So now I do it and I should get a very simple value. So 24 divided by 3 is 8 and we divide the vector. So I get a result as a vector which is a vector 8, right? Now, say for example, I just make it a 0. So I'm trying to divide by 0 and it's a handled exception, 0 division. Let me try to do that. Yes, it is just returning me a nan, not a number. Obviously, when I'm trying to divide some number by a 0, the number which I get is a, we call it infinite, or it's not a defined number, right? Now, say for example, I give something which is not handled in the right way. So say for example, I give a character, okay, non-numeric vector as the first vector, and the second one is a numeric. Now when I do it, I get unsupported operand type, this kind of an error, right? So when I get this kind of an error, obviously this is a very small piece of code, we can figure this out. But when we have a very large piece of code, when this type of an exception is being thrown, or when the program when running we get this kind of an exception, we are completely in a loss, right? So how do we handle that? So in case we want to handle that, we have to, again, for any other, so we give a error which is known, okay, an exception which is a expected exception. For the other exceptions, what we do is we raise a exception of type value error, which is a built-in type, right? Now if I do it, now the message which I get is a more specific message. See, here we get a value error, get ratios called with bad arguments. So here what we get is a very, very valid kind of a error, right? Or a very valid kind of a alert, right? From this, obviously, the user can get a very clear understanding what is happening here. And then when you get this, you can also try to have it handled, right? So this is how we can raise exceptions on our own, right? Same way, I mean, just like exceptions, we can also have Python asserts. What is an assert? So Python assert statement provides programmer with a simple way to confirm that the state of the computation is not as expected. Something abnormal has happened. So one is you can raise the exception and handle that. Otherwise, you can also have an assert. Okay. So how do we write an assert statement? Simple. Assert and then a Boolean expression. Or the other way is assert and give you a Boolean expression along with an argument. So when the assert statement is encountered, okay, if the value is as per expected, right? When the Boolean expression is evaluated and when the value is true, nothing happens. Okay, but in case the Boolean expression which we get, say the Boolean expression may be a comparison between two variables or whatever, if that fails, immediately an assertion error exception happens. So assertion error is basically another type of exception. So that happens. You may ask that why is it needed? Again, it's a very, what should I say, proactive defense mechanism when you are writing a program, right? So this defense mechanism actually helps in raising an error or raising an exception. And whenever an exception is raised, you have the try except blocks where you can handle the exceptions being raised. So it's a proactive way to throw an exception whenever you come across a unexpected situation and then handle that exception, right? So this is how we can raise assertions. So I think that is all related to exception handling in Python. I think it's a very important practice whenever we try to write industry grade programs. Writing the codes in exception blocks or try exception blocks is a must. There is no other option than doing this. Okay. So that's all I had for this particular module, exception handling. So stay tuned for the remaining modules. Thank you very much.